This is the Robert Joodat Podcast. Refined conversations on love, attraction, and becoming your best self. Stay curious.
Right now, without you doing a single thing, your brain is running a biological program that is shaping who you find attractive, how intensely you feel it, and whether you even want to stick around after. And the wild part, you have almost no conscious say in any of it. Today, we're getting into mating hormones, specifically what they actually are, how they wire your brain for attraction and long-term bonding, and what brand new science is revealing about why your feelings shift in ways that feel completely out of your hands. By the end of this episode, you'll understand the 3 distinct systems driving your love life and why the same person can feel completely different to you at different moments. I've got someone here who has been deep in this research, so let's not waste any time, break it down for us. What is actually happening inside us when we're drawn to someone?
So the first thing to get straight is that what we casually call being attracted to someone or falling in love is not one thing. According to research published in the Indian Journal of Endocrinology and Metabolism by Dr. Krishna Seshadri, lust, attraction, and attachment are actually 3 distinct but deeply intertwined processes in the brain, and each one runs on its own set of neurotransmitters and circuits.
Wait, so they're separate? Like 3 different programs running at once?
Exactly. And here's what makes it even more interesting. Those circuits feed on and reinforce each other. So they're distinct, but they're not isolated. Seshadri describes love as, and I love this framing, an emergent property of an ancient cocktail of neuropeptides and neurotransmitters. It's not one chemical. It's a whole recipe.
An ancient cocktail. That's a phrase I'm going to be thinking about for a while. So what's in the cocktail? Like, what are the actual ingredients?
So for lust specifically, the key players are testosterone and estrogen, and the amygdala is a central hub for that. For attraction, you're looking at dopamine, norepinephrine, cortisol, and the serotonergic system, with the nucleus accumbens and the ventral tegmental area as the key brain regions. And then for attachment, that's where oxytocin and vasopressin come in.
Okay, so dopamine I've heard of, cortisol I've heard of, that's the stress hormone, right? But why is a stress hormone involved in attraction?
That's actually one of the most counterintuitive parts of this whole thing. Tom Sherman, a neuroendocrinologist at Georgetown School of Medicine, explains it really well. He says that falling in love often has this inherent uncertainty to it. You don't know if this person likes you back, you don't know what's going to happen, and that uncertainty gets processed as a kind of stress. So cortisol spikes, which actually heightens your sense of awareness and sharpens your focus on that person.
So the nervousness you feel around someone you like is literally your stress response firing?
That's exactly what Sherman is describing. And at the same time, dopamine is doing its thing. When your brain associates a person with something pleasurable, like meeting a promising potential partner, it releases dopamine to reinforce that feeling and push you to seek more contact with them. Sherman puts it really plainly. The brain areas that would normally say, "Be careful, you don't know this person," get turned down, while the areas screaming, "I can only think about this person," get turned up.
That is kind of terrifying when you say it like that. Your own brain is suppressing your judgment.
Sherman actually calls it being on autopilot, intoxicated by a love potion. And his point is that love may not be a choice, it may just be your brain doing what it was built to do.
Okay, so that's the attraction side. But how do these hormones actually get set up in the first place? Like, is this something that happens at birth, or is it more ongoing?
This is where it gets really foundational. Research published in the journal Endocrinology by Kimberly Jennings and Louise Delassay at Oxford Academic lays this out clearly. Gonadal hormones, so testosterone and estrogen, actually shape the brain from very early on. Perinatal exposure to these hormones guides things like neuronal growth, synaptogenesis, and even epigenetic modifications to build what they call sexually dimorphic neural circuits.
So the architecture of how you experience attraction is being laid down before you're even aware of it.
Right. And then later in life, those same hormones come back and activate those circuits. That's the actual term they use. Organizational and activational effects. The early exposure organizes the structure, and then hormones throughout your life activate it. So it's a 2-stage process that spans your entire lifespan.
That's a really different way to think about it. It's not just what's happening in the moment. There's this whole developmental history baked in.
Exactly. And the Jennings and Delasay review also makes this point that sexual behavior is strongly dependent on circulating gonadal hormones in both sexes, but the specific circuits involved in males and females are overlapping yet distinct. So there's shared architecture, but it doesn't produce the same outputs.
Okay, let's get into that because I want to talk about something that I think is going to genuinely surprise people. There's new research out of Rockefeller University that just dropped in 2025 that kind of blew my mind when I read it. Can you walk us through what they found?
Yeah, this one is wild. So, researchers at Rockefeller University's Laboratory of Molecular Biology, led by Nathaniel Heinz, published a paper in the journal Cell. They identified a specific subset of neurons in the prefrontal cortex, the CACNA1H positive neurons, that control what they call sociosexual behaviors. And these neurons integrate signals from oxytocin, ovarian hormones, and social cues all at once.
So it's like a convergence point for all these different signals.
Exactly. And here's the part that really gets you. When they activated this circuit in female mice, the females became more interested in mating. Even non-fertile females became receptive. But when they activated the exact same circuit in male mice, the males became less interested in mating. Same switch, completely opposite outcome.
Wait, the same circuit does the opposite thing depending on whether you're male or female?
That's exactly what they found. And when they silenced the circuit in females during their fertile phase, the females lost interest. So it's not just that the circuit drives mating, it's the primary gatekeeper of when and whether mating interest turns on at all. Co-author Kun Lee described it as shared circuitry flexibly sculpted by both hormonal state and biological sex to produce sex-specific patterns of social behavior.
That quote is doing a lot of work. Flexibly sculpted. So the same hardware, different software depending on your hormonal context.
That's a really good way to put it. And the other thing they found is that this circuit has a feedback loop. The neurons both drive mating-related social interactions and get activated by them. So the behavior itself reinforces the hormonal state that's producing the behavior.
So it's self-reinforcing. The more you engage, the more the circuit fires, the more you want to engage.
Which starts to sound a lot like what Sherman was describing with dopamine and the reward circuit. These systems are all talking to each other.
Okay, I want to zoom in on something that I think is going to be really relatable for a lot of people. This idea that your preferences aren't fixed. Like, the research suggests that who you're attracted to can actually shift depending on your hormonal state at a given moment. Can you get into that?
Yeah, this is one of the most practically interesting parts of all this. Research published in the Journal of Psychological Science reviewed how sex hormones affect mate preference. And what they found is that women's mate preferences actually track changes in hormone levels across the menstrual cycle. Specifically, estradiol and progesterone are the key hormones here.
So your preferences literally shift month to month?
That's what the research indicates. During the late follicular phase, which is the fertile phase, when estradiol is higher, women tend to prefer men who show more masculine traits, which are thought to signal underlying health and genetic quality. But during low fertility phases, the preference shifts toward men who display more nurturing, stable qualities, what the researchers describe as good husbands and good fathers.
So it's like your biology is running two different optimization strategies at different times.
The researchers actually call it the dual mating strategy. It's a trade-off between good genes and good parent. And the idea is that no matter which type of partner is preferred at a given moment, the underlying goal from a biological standpoint is to maximize reproductive benefit. It's not random. There's a logic to it.
That's kind of a lot to sit with, because we tend to think of our preferences as just who we are. But this is saying they're at least partly a moving target driven by biology.
And it goes both ways. The same Journal of Psychological Science review found that men's mate preferences are also hormone dependent. When testosterone levels are higher, men show increased preference for feminine facial features in women, which are associated with reproductive potential. So it's not just one sex experiencing this. Hormones are modulating preferences across the board.
And there's also that separate study on short-term mating intentions, right? Where estradiol and testosterone were specifically linked to openness to short-term partners.
Yeah, that research found that increases in estradiol and testosterone across the cycle were associated with increases in short-term mating intentions, specifically responsivity to potential short-term partners. Interestingly, progesterone showed no such association, and neither did intentions around long-term partners. So the hormonal influence is quite specific in what it targets.
That's a really precise finding. It's not just hormones make you want to date more, it's specifically about short-term responsivity.
Right. And UC Santa Barbara researcher Jim Roney, who runs the Human Behavioral Endocrinology Lab, has done extensive work on this. His research published in Hormones and Behavior found that women's estradiol levels actually predict their preferences for facial cues of men's testosterone. So your hormone level is predicting what face you find attractive. That's a pretty direct link.
Okay, I want to pivot to the bonding side of this because attraction is one thing, but what keeps people together? That's where oxytocin comes in, right?
Oxytocin is fascinating because it does so many things. It originates in the hypothalamus and gets released by the pituitary gland. Most people know it as the love hormone or the bonding hormone, and that reputation is earned. It contributes to strong social connections, including the parent-infant bond and romantic attachment. But it also enhances social recognition, meaning it helps you identify and remember specific people.
So it's not just making you feel warm and fuzzy, it's also helping you lock in who that feeling is attached to.
Exactly. And according to Biology Insights, oxytocin also reduces fear and stress responses in social contexts and promotes trust and empathy. So it's essentially lowering the defensive walls that would otherwise make intimacy harder. It works by binding to oxytocin receptors throughout the brain and body, modulating the neural circuits involved in social cognition.
And then there's vasopressin, which, I'll be honest, I only knew as a kidney hormone before I started looking into this.
Yeah, vasopressin has a bit of a branding problem. It's technically the antidiuretic hormone. It regulates water reabsorption in the kidneys, but it's also been implicated in social behavior, aggression, and pair bonding in certain species, with research exploring similar roles in humans. It's synthesized in the same place as oxytocin, the hypothalamus, and released from the same gland. They're kind of siblings with very different day jobs.
That's such a weird double life for a molecule, keeping you hydrated and keeping you loyal.
And the 2025 MDPI review on the molecular basis of love, published in the International Journal of Molecular Sciences by researchers at Comenius University, pulls all of this together. It looks at dopamine, oxytocin, vasopressin, and serotonin as the key hormones and neuromodulators shaping attraction, attachment, and long-term bonding. And it also raises something that I think is really relevant right now, the potential impact of modern lifestyle factors on hormonal balance and how that affects love and social interactions.
Modern lifestyle factors? Like what? What are we talking about?
Well, one that really stands out from the research is sleep and circadian rhythm disruption. A 2025 review published in Frontiers in Neuroscience by researchers at Harvard Medical School and Northeastern University looked at how the circadian clock regulates sexual and reproductive function. And what they found is that misalignment of biological rhythms from things like repeated shift work or chronic jet lag negatively impacts reproduction by interfering with both male and female fertility.
So your sleep schedule is affecting your hormones, which is affecting your mating biology.
Specifically, the research shows that disrupted circadian timing negatively impacts sex hormone levels and semen quality in males and leads to ovulatory deficiencies in females. And the WHO data they cite is striking. Approximately 17.5% of reproductive-aged adults, or about 1 in 6 people, experience infertility. That's a global public health problem, and circadian disruption is one piece of that puzzle.
1 in 6. That's not a small number. And it's not just about having kids, it's about the whole hormonal ecosystem that governs how you connect with people.
That's the right way to frame it. The hormones we're talking about, testosterone, estrogen, oxytocin, dopamine, they're not just fertility hormones. They're the infrastructure of how you experience desire, connection, and attachment. When that infrastructure gets disrupted, it affects everything downstream.
I want to go back to something you said earlier about the 3 systems: lust, attraction, attachment, being distinct but reinforcing each other, because I think there's a really important implication there that we haven't fully unpacked. Like, what does it mean that they can operate somewhat independently?
It means you can experience them in different combinations and at different intensities. You can have strong lust without deep attachment. You can have deep attachment without the initial lust still being present. And attraction, that dopamine-driven obsessive focus, can fade even when attachment remains strong. These aren't stages that replace each other. They're parallel systems that can be running at different levels simultaneously.
Which actually explains a lot about why relationships feel so different at different points. Early on, it's all dopamine and cortisol and this intense focus. And then over time, it shifts toward the oxytocin and vasopressin side.
That's a really accurate read of what the research suggests. And it also explains why the early intensity of attraction doesn't have to be the benchmark for whether a relationship is working. Those are different biological systems doing different jobs.
Okay, I also want to bring up something from the Roney Lab research at UC Santa Barbara because I think it adds a layer that's easy to miss. His work looked at whether men's hormones respond in real time to social interactions with potential mates. What did that show?
So, Roney and colleagues published research in Hormones and Behavior showing rapid endocrine responses in young men during social interactions with young women. Meaning testosterone levels were shifting in response to the social context itself, not just as a background state, but as a dynamic response to who you're around. It's bidirectional. Your hormones shape your behavior, but your social environment is also shaping your hormones in real time.
So it's not just that your hormones determine who you're attracted to. The act of being around someone you're attracted to is changing your hormonal state.
Which loops back to what the Rockefeller study found about the feedback circuit in the prefrontal cortex. The behavior activates the neurons drive more behavior. It's a system that builds on itself.
And that's also consistent with what Sherman said about the reward circuit, dopamine reinforcing the behavior of seeking more contact. All of these findings are pointing at the same underlying architecture.
Exactly. And I think that's actually the most important takeaway from all of this research. It's not one hormone, one circuit, one moment. It's a deeply integrated system where hormones, neural circuits, social context, and behavior are all in constant conversation with each other.
Let me push back on something slightly, though, because there's a risk here of making it sound like we're just puppets of our hormones. Is there any nuance in the research about the limits of hormonal influence? Like, where does biology end and choice begin?
That's a fair challenge. And the research is actually pretty careful about this. The MDPI review notes that while passionate love has a biological basis, the frequency with which people experience it can vary depending on cultural context, social structures, and belief systems. So biology sets the stage, but it doesn't write the whole script. The Jennings and Delasay review also acknowledges that the neural circuits mediating sexual motivation in males and females are overlapping yet distinct. There's variation, not determinism.
So it's more like hormones are setting the parameters, and then everything else, your history, your values, your context, operates within those parameters.
That's a good way to put it. And the dual mating strategy research is a good example. It describes tendencies and shifts in preference, not rigid rules. The biology creates a pull, but people navigate that pull in all kinds of ways.
Okay, so when you step back from everything we've covered today, here's what I keep coming back to. We walked in thinking about mating hormones as this kind of simple, almost embarrassing biological thing. And what we've actually uncovered is this incredibly sophisticated, multi-layered system.
And what I think is most valuable about understanding it is that it reframes a lot of experiences that people tend to judge themselves for. Why did I feel so intensely about someone and then it faded? Why do my preferences feel different at different times? Why does being around a certain person change how I feel about myself? These aren't failures of character, they're features of a biological system doing exactly what it was built to do.
And the three-system model is really useful for that. Lust, attraction, and attachment, each running on different chemistry, means they can be at different levels at the same time. And that's normal. That's not a contradiction.
Right. And the Rockefeller finding adds something really important to that. Even the same brain circuit can produce completely different outputs depending on your hormonal state. So the idea that your experience of attraction is fixed or consistent is just not supported by the biology. It's dynamic by design.
And then the circadian piece is the one I think people are going to find most actionable, because you can't easily change your testosterone levels or your estradiol cycle, but you can protect your sleep. And the Harvard Medical School research is pretty clear that disrupting your body clock has real downstream effects on the hormones that govern all of this.
That's the most concrete lever people have. The Frontiers in Neuroscience review makes the case that proper circadian clock function is foundational to reproductive hormone health, and that misalignment from things like chronic shift work or jet lag can interfere with fertility and sex hormone levels in both sexes. It's not a minor effect.
So if you're someone who's been wondering why your energy, your drive, your interest and connection feels off, your sleep schedule is a legitimate place to look.
And more broadly, understanding that your hormonal state is dynamic, that it responds to your environment, your behavior, your sleep, your social interactions, means you have more agency than the autopilot framing might suggest. You're not just a passenger. You're also shaping the conditions that shape your hormones. That's a really good place to land. Here's what I want to leave people with. At the top of this episode, I said your brain is running a biological program and you have almost no conscious say in it. And that's true. But what you now have is the ability to read the code. You know that lust, attraction, and attachment are three separate systems. You know that your preferences are hormonally modulated and shift over time. You know that the same brain circuit can produce opposite effects depending on your hormonal state. And you know that your daily habits, especially sleep, are actively shaping the hormonal environment that drives all of it.
And knowing the code doesn't make the feelings less real, it just makes them more legible.
That's what all of this research is ultimately pointing toward, a richer understanding of why we connect the way we do.
Beautifully put. Thanks for being here, and thanks to everyone listening to Co-Pilot Podcasts. Your brain was running a program before you hit play today. Now you actually know what it's running.